In this video, we will discover how we can set up multiple different authentication mechanisms with Spring Security, and you will learn how exactly does all this stuff work behind the scenes. We will spend just a couple of minutes on this screen to explain what are the key interfaces in Spring Security that we need to know of and how they are connected. Right after that, we will jump into coding. What exactly do I mean by multiple different authentication mechanisms? Here's an example. You want your server to authenticate requests coming from the client using JSON Web Tokens, but you want requests coming from other servers to be authenticated with API keys. This is a common scenario. What we will not cover in this video, however, is auth providers, which might be what you're looking for. I'm going to soon cover this on this channel as well. We will break down the auth flow with Spring Security exactly in the same way we will do it here. I'm not going to just tell you to do something without telling you why. Subscribe if you don't want to miss that out. There are three interfaces that you need to remember. Every authentication mechanism will use the same three interfaces, only their implementation will differ. They are filter, authentication, and authentication provider. Filter is usually a class which extends once per request filter. It is a middleware that will run some code before your request reaches the request handler. You can have many filters, and Spring Security adds a dozen already on its own depending on your configuration. These filters constitute a filter chain. Somewhere in the middle of this chain you would usually have your authentication related filters. The point of an authentication filter is to identify the user based on the request, and as you can imagine, this can be done in a multitude of ways. This filter will then create an instance of an authentication and pass it to the authentication manager to authenticate. You can see that on the diagram. API key authentication filter will construct an instance of API key authentication token and send it to a provider manager. Provider manager will then find a provider which supports API key authentication token, and it will delegate the authentication to this provider. Enough talking, let's now see how this works in practice. I've prepared as some starting point here. As you can see, we are using Spring Boot 3.2 and I have added three dependencies. That is Spring Boot Starter Security, Starter Web, and Lombok. I have also added some basic security config here. We define our own security filter chain, so we are overriding any auto configuration that Spring Security Starter is giving us. And at this point in our application, we have absolutely no protection and we have no authentication mechanisms. We can prove that if we start the application and we check out the filter chain, we will see that the last chain in the filter chain is not authorization filter, which is the filter that is responsible for protecting our endpoints, and we also don't have any authentication related filters except the anonymous authentication filter. And so we also added a controller that we will use for testing. It is at path API/protected. And if we would just now try to access this route, we will see that it works without any problems. From the introduction that you saw before, we had an example where we will use API key authentication type, and we will start building that. That will be one of our authentication mechanisms. And the other authentication mechanism is going to be HTTP basic. Hey, it's me from the future. I failed to mention here that there is a specific reason why we want to use basic here. Keep watching and you'll find out why. Let's first start by adding the authorization filter to our chain so we can actually protect our endpoints. Let's say authorize requests, and let's say customizer is going to say any request should be authenticated. If we would now restart the application again, we would see that the last filter in the chain here would be authorization filter. And basically the point of this filter is to check if we have authentication on the security context holder, and it makes a decision if we can access that endpoint that we are trying to access or not. Actually, it works with all the rules that we define here. So now we said that any request should be authenticated, but we can define many different rules based on roles or whatever here as well. In case this authorization filter is deciding that we cannot access the endpoint, then it will throw the access denied exception, and then this exception will be handled by the exception translation filter. And exception translation filter is then using the authentication entry point to handle the case where we cannot access the endpoint. So what should we do next? and the default, as you can see now, let's just try to run this again. Let's just see, do we have authorization filter here? Yes, we do. And if we try to access API protected, you will see that we get error response 403. And I can just quickly show you where this happened. If we go into exception translation filter, oh no, that's not what I want. Translation filter, it happened exactly here. So first, let's first start from authorization filter. This is where the filter decided that we cannot access this endpoint. It threw the exception, and then exception was handled here inside this filter, which is in the end, you will see, going to use the authentication entry point and invoke the commands. And the default entry point is going to be HTTP 403 authentication entry point, which is doing exactly what you saw in the browser. It just returns us this response with 403 status code. You can also define your own entry points for different authentication mechanisms that you can use. For example, if we say here HTTP basic and we say customizer, then we can define our own different entry point. We can say customizer entry point. You'll see that we can provide our own. So I just wanted to explain this part as well, because it might not be obvious to everyone why did we get this error here and how did it happen. So that's basically that. Now we can now start actually configuring the HTTP basic, and I will get to the point why exactly did I want to use this and not create our own. So basically the point of this video is that we can have multiple authentication mechanisms, and you know, it's kind of obvious already by using Spring Security Starter. You already have login with form login, and you already have basic authentication at the same time. But you will see there is a twist there as well, because they are both using the same authentication token and the same provider. But we are going to get around this in just a second. So if we say HTTP basic, I think we can just say something like with defaults like that, and then we will have some basic authentication with some defaults that Spring Security will provide us with. And let's say that if we start the application now, we will see in our chain we should have basic authentication filter here. And here you can see that this filter is extending the once per request filter, and as I said in the introduction, this is usually what you would do when you define your own filters, and that's what we will do when we do define our own filter. But let's now see what happens here in doFilter internal. Authentication object will be created, and for basic authentication filter they are using the authentication converter here. But if we check what actually happens, authentication converter is basic authentication converter, and we check the convert method will actually return username password authentication token, which is a type of authentication. And what happens next in the basic authentication filter, when this token is created, it will be sent to the authentication manager to authenticate, and as you can see, authentication manager will return the same thing. It is just then the result of this authentication. So this can then be fully authenticated or not authenticated. But either way, this is set on the security context holder, and then the last filter in the chain, authorization filter, will check if we need the request to be authenticated or not and decide what happens. But where I'm going with this is that if we try to follow through what happens, because if we remember what I said in the introduction, this token is passed to the authentication manager, which is going to be the provider manager. And if we try to find what happens there, we will see that the provider manager is looping through the list of providers, and then when it finds the provider which supports this kind of token by checking the supports method. Then it will try to authenticate the token. If we would now start the application with a debugger, we would see that the provider used for username password authentication token is called the authentication provider. And why is this important? I just want to say that most tutorials out there will just tell you the way you implement authentication with Spring Security is by providing some user details service, and then also your user needs to be extending the user or implementing user details interface, but there is absolutely no explanation why do you need to do that. And basically the reason why do you need to do that is you are using username password authentication token. But do you need to use username password authentication token? No, you don't. And this is what most people miss to point out. You absolutely do not have to use username password authentication token. It is used by Spring Security for basic authentication, and it is used for form login. But if you do not want to use these two, then you should probably create your own token. You should not use username password authentication token. And you might now be wondering, but why are you then going to use HTTP basic, which is basically working with username password authentication token, if you do not want to use the user details service? And that is exactly the point. I want to show you that this thing is not written in stone. You do not have to use user details service, and you can configure this any way you like, and I'm going to show you how. So first, let's create a package here that is going to be called providers, but without capital letters, providers. And then let's create our first provider, which is going to be basic authentication provider. And this class should implement authentication provider, not converter, authentication provider, like that. So it has two methods that we need to implement: authenticate and support. And as I said before, we are going to work with username password authentication token still, but we are no longer going to use DAO authentication provider. We are going to use basic authentication provider. And how do we do that? Well, we just check here if the provided authentication or class of authentication is equal to username password authentication token. So now this basic authentication provider is what is going to be used for this type of token. And for the authenticate method, we are just going to hard code some result here. We are not going to actually use a database or anything like that. You would usually have some kind of a service injected here, and then you would pass the token to the service, and service would then go maybe fetch user from the database or whatever. But for our purposes, we are going to just do it like this. We are going to say that our token is going to be username password authentication token, because that is what we expect. And we are going to cast it like this, and then we are going to check, or we are going to get the name and the credentials. And here we are just going to say that only if username is equal to test, and this should really be equals. So let's say test equals username, and test equals password. This is the only case where we would return new username password authentication token, and then we would pass the same username and password and authorities. And this is a bit specific with username password authentication token. This here constructor will be used to set the authenticated flag to true. So you should not use this constructor because it will set the authenticated to false. This is the one that you should use, because for our case here, this is the case when we say, okay, our request is authenticated and here is your authentication token. So this will now be returned to back to the filter, which would set it to the context holder. But in case we do not authenticate the user, we would just return the authentication that we received, because it is not authenticated and it will not work when it reaches the authorization filter. So this is now our basic authentication provider, and if we go back to security config, what we need to do now is we need to provide our own authentication manager. So we will provide a bean of authentication manager, which is going to be it's going to be returning a new provider manager, like that. And provider manager constructor here, as you can see, can take a list of providers, and this is what we are going to do next. First, let's create basic authentication provider. Is going to be basic authentication provider, and then we are just going to pass it in to the provider manager. So now, as you can see, we are using basic, and we will be using username password authentication token, but we will not be needing to provide our own user detail service or anything similar. Let's now see if this works. If we try to access our protected endpoint, we will see that we get this response. It is asking us for credentials, and basically this is the work of HTTP basics authentication entry point, which we could customize. If we just said a customize authentication entry point and we did something else, then we might have an error different than the one that we got before. But we are not going to do that. Instead, now what we are going to do is we will create some basic authentication header here, which is going to have username as test and password as test. And as you can see, this is then the header that we need to use. So if we now send a request like this, we should get a successful response. And as you can see, we get success. So we did not use user detail service, but we made basic authentication from Spring Security work. Okay, so that is one of the providers out of the way, and we said already that our next provider is going to work with API tokens, and let's just start working on that. Again, we are going back to the diagram. First thing that we need is the filter, and we will call this filter API key authentication filter. And as we said before, this will extend once per request filter, and then we need to implement some methods, that is do filter internal. Let's say that for our example we want the request to contain some header by name X API key, and then based on this API key we are going to construct a authentication of type API key authentication token. So before we can continue working on this filter, we should then first create API key authentication token, which is going to be implementing the authentication interface, and then we will need to implement some methods. We really do not care here about any of these. I mean, we should probably care about principal. Usually this would be your user object, so when you authenticate the request, you would then collect the user details from your database or whatever, and you would set the principal here to be that thing. And also this one is important because it is telling the authorization filter if the request is authenticated or not. So let's just keep a variable here of is authenticated, and we will return is authenticated. One more thing that we are going to need here is a string that will hold API key like that, and we will also say that is authenticated by default is going to be false. And then we are going to have a constructor that will take an API key, and let's say it will take both of these. So then we can also omit that, and we can say that API key is what we receive here in the constructor, and also is authenticated is going to be what we receive in the constructor. This means that both the variables can be final. And so now we are ready to start using the API key authentication token from our filter. So let's get back to implementing the API key authentication filter. As we said earlier, we will want to look for a header with name xAPI key, and that will be our API key. So let's say request get header xAPI key, and in case we do not have an API key, what do we want to do? Maybe we just want to log something out, and then we want to continue our filter chain. This will mean that once the request reaches the authorization filter, we will still have no authentication on the security context holder. And in case we do have an API key, then we want to build an API key authentication token, and we will build it like this, but we want to say authenticated initially is false. Then we want to use authentication manager to authenticate this request, but here, as you can see, we do not have authentication manager. Then what it means is it means that we will have to add it. So let's say private final authentication manager and then let's also create a constructor like that. So we have now access to authentication manager, and we are going to say API key authentication token. Result is going to be this authentication manager authenticate authentication. I don't know why is this complaining though. It says required type is API key authentication token and provided here, okay, this is the issue, authentication. The result is of type authentication. And what do we want to do next? Well, we said it already. We say security context holder, and we say get context, set authentication, and we pass in the result. API key authentication filter is basically done. We have created API key authentication token. What else do we need? We need API key authentication provider. Let's create that, and that is going to implement authentication provider. We already saw that before, and we should probably put this here in the same package as the other provider. And let's just implement the same methods again. This provider supports the API key authentication token class equals authentication like that, and the way we will authenticate this request is again going to be hard-coded in our case, but you could use the service or whatever you want here. Here we are going to say API key authentication token. We are going to first cast this so we can access the API key. It's not going to be a principal, and we are missing a getter for this, so let's just say create getter like that, and now we can use the getter here, token get API key, and now we are going to say if API key equals let's say 1 2 3 4 5, but we in that case want to return the new token which is going to be authenticated. That's exactly what we want, and in case it's not authenticated, we are just going to return the same authentication which we received, which is going to be not authenticated. And that's it. Now we have to go back to security config, and we are going to register this provider the same way we registered the previous one. We will say API key authentication provider is a new provider, and we are going to pass it to the provider manager like that. And now if we would try to start the application, it of course would not work, and it would not work because We have created our filter, but this filter will not find itself in the security filter chain. We have to register it, and to do that we are going to say http add filter before. So here we are going to say new API key authentication filter, and we are passing in the authentication manager bean because that's expected here. And where do we want to put this filter? We want to put it right before the logout filter, but we could have also done this differently. We can say before basic authentication filter, like that. Let's do that. So if we start the application now, we should see that if we send a request with API key 12345, we should be let through. Let's turn this off and let's say X API key is going to be value of 12345, and if we send a request we should get hello world, so this is a success. And if we send some request that isn't correct, we should get 401 unauthorized. Let's just see that the basic is still working fine as well. As you can see, it does, and if we change this, it doesn't. That is all for this video. I hope you enjoyed it and you learned something new. Let me know in the comments down below if you'd like to see more Spring Security related tutorials. Until next time.